You know, in the world of process improvement, just having a gut feeling can be really, really dangerous. So today, we're diving deep into the measure phase of Six Sigma. This is that critical step where we stop guessing and we start knowing. It's where we trade in our vague suspicions for a crystal clear, data-backed picture of what's actually going on.
I mean, who knew Ferris Bueller was a process improvement guru? But he was totally onto something. This applies perfectly to business. If you don't stop and actually measure what's happening in your processes, you can't possibly understand them, let alone make them better. The measure phase? Well, it's all about taking that deliberate, hard look around.
So, we're going to approach this whole thing like a 5-stage investigation. First up, we'll talk about making that leap from just guessing to actually knowing. Then, we're going to draw a map of our crime scene. After that, it's all about the hunt for hard data, the clues. Next, we'll figure out how to turn those clues into real insights. And finally, we'll deliver the verdict. What's our process's current score? Okay, so let's begin the investigation. The measure phase is the second step in that whole DMIC framework, right? It comes right after you've defined the problem, and its entire purpose is to get the real story. We're moving away from anecdotes and, I think this happens, to establishing a factual baseline, using nothing but cold, hard data. This phase has a really clear mission. First, we have to establish a performance baseline. Why? So we actually know if our changes are making things better later on. We've got to define what to measure and figure out how we're going to collect that data. And this one is huge. We have to validate our measurement system to make sure it's reliable. And finally, we get to determine what the process is truly capable of right now. So where do we start? Well, just like a detective showing up to a crime scene, your first job isn't to start bagging up evidence, it's to understand the layout. In Six Sigma, this means we've got to visualize the entire process before we even think about measuring a single thing. And a process map is our absolute primary tool for this. When you create a process map, you're forced to see every single step, from the very first input to the final output. It's a brilliant way to see where things might be going wrong, where the bottlenecks are, and, most importantly for this phase, it points a big, flashing arrow at the critical steps where we need to be collecting our data. And of course, we have other tools in our detective kit. A value stream map is fantastic for seeing which steps actually add value and which ones are just waste. A spaghetti diagram, well, it literally tracks the physical path that people or products take. And believe me, it often reveals a total mess. And then the cause and effect matrix helps us connect the things we do in the process to what our customer actually gets and cares about. All right, our map is drawn. We know the layout of the land. Now the real investigation kicks off. It's time to gather the clues, the evidence. It is time to go on the hunt for some hard data. Now, we don't just start grabbing numbers at random. That's a recipe for disaster. A solid data collection plan is absolutely essential. We have to define our goals. What are we trying to prove? We need clear operational definitions for things like a defect, so everyone is on the same page. And we have to figure out how much data we actually need to get a reliable picture. This plan makes sure every single data point is a useful clue, not just background noise. Now, the clues we gather, they're going to come in two main flavors. You've got discrete data, which is anything you can count, the number of mistakes, the number of complaints, it's whole numbers. Then you have continuous data, which is anything you can measure on a scale, like how long it took, how much it weighed, how tall it was. And trust me, knowing which type you're dealing with is key to analyzing it the right way later on. Okay, this next part is so critical. If our measurement tools, our metaphorical magnifying glass, are flawed, then all of our evidence is tainted. It's useless. Think about a target. Accuracy is asking, are we hitting the bullseye? Precision is asking, are all our shots landing in the same place? You absolutely need both, because a precise but inaccurate tool is just going to give you the same wrong answer over and over again. So this brings us to a formal check called a Measurement System Analysis, or MSA. This is how we prove, scientifically, that our data is trustworthy. It uses some fancy techniques, like a gauge R&R study, to answer a really simple question. If two different people measure the exact same thing, do they get the same result? We're basically measuring our own ability to measure things well. So we've collected our box of clues. It's full of numbers, observations, all sorts of stuff. Now comes the really fun part, organizing all this raw evidence to see what kind of story it's trying to tell us. It's finally time to turn all that data into real, actionable insights.
You know, the very first step in making sense of all this chaos isn't some complex statistical analysis. It's just making it visual. Simply plotting our data in a chart can reveal patterns that a giant spreadsheet of numbers would completely hide. It is the single most powerful first step you can take to find the story inside your evidence.
And we have some key tools for this. A histogram is great for showing us the shape and the spread of our data. A Pareto chart, oh, this one is so powerful. It uses the 80-20 rule to pinpoint the vital few problems, like maybe two specific types of errors that are causing 80% of all our headaches. Then you've got a scatter plot, which helps us see if two things, like say training hours and error rates, are actually connected.
So along with those visuals, we use what's called descriptive statistics. These are just the fundamental numbers that summarize our data set. You've got the mean, which is the average, the median, which is the middle value, and the standard deviation, which tells us how spread out everything is. Think of these numbers as the headlines of your data's story.
Okay, deep breath. We've mapped the scene, we've gathered the evidence, we've analyzed the clues. Now it is time for the big reveal. This is the climax of the measure phase, delivering the final, data-driven verdict on how our process is actually performing. And this is the ultimate question we've been trying to answer. What is our process capability? See, this isn't just about how our process is performing in a vacuum. It's about whether it can consistently deliver what the customer actually wants. It's a direct comparison of the voice of the process, what we're actually making, to the voice of the customer, what they expect to get.
And this number right here, this is the gold standard. The goal of a Six Sigma level process is to produce just 3.4 defects per million opportunities, or DPMO. And that O for opportunities is so important. It means for every million chances there are to create a defect, only 3.4 actually happen. That is a level of quality that is pretty much perfect.
What's so amazing about calculating a sigma value is that it translates quality into a universal language. It lets you compare the quality of a call center's response time with the manufacturing precision of a jet engine. It's one single, standardized score for performance that works across any industry. So, at the end of our whole investigation, we get to compile our final case file, and it's got everything. Our detailed process map, all the data we painstakingly collected, the proof that our measurement system was valid, our charts and graphs, and that final, all-important process capability score. This entire file then becomes the rock-solid foundation for the next phase, analyze. And that's the journey of the measure phase right there. We've gone all the way from assumptions and stories to a factual, data-backed understanding of the current reality. We've laid the foundation, and it's on this foundation that all real, meaningful improvement is going to be built. So, I'll leave you with this question to chew on. What's one important process, maybe in your work, maybe just in your life, where you're just relying on a gut feeling instead of actual data? What do you think would happen if you really stopped to measure it? That's all we have for this explainer. Thanks for joining me, and we'll see you next time as we continue to turn complexity into clarity.